Hello friends, very good morning to all of you. So today we are going to talk PF54 part 4.1. So in PF54 we talked about the registration of redirect URI. So in the same session we have again like sub parts for that. And in this session we'll talk about stealing the authorization code through the referrer. How you can steal the authorization code through the referrer and how we can protect that. So this is PF54 part 4.1. So let's begin and we can discuss.
Friends, so yeah, today we'll discuss the 54 part 4.1 in continuation of the registration of the redirect URI. So in this session we'll try to understand that how there is a way to steal the authorization code through the referrer and maybe how we can avoid it also. So let's jump to the first slide. So the first attack described targets the authorization code grant type and is based on the information leakage through the HTTP referrer. At the end of it, the attacker manages to hijack the resource owner authorization code. To understand this attack, it is necessary to know what a referrer is and when it is used. So we just need to understand few things. Then only we can understand how the attacker can hijack the authorization code through the referrer. So the HTTP referrer is an HTTP header field that browsers attach when surfing from one page to another. Okay, so in this way the new web page can see where the request came from, such as incoming link from a remote site. Okay, so basically the HTTP referrer is the HTTP header field that browsers are basically attaching when surfing from one page to another. Like we are going from one website to another website, so that browser is attaching that link, I can say the previous site, in the form of referrer, right? Now there is a problem in that we'll understand in the session. Okay, so let's assume you just registered an OAuth client to one OAuth provider that has an authorization server that uses the allowing subdirectory validation strategy for redirect URI, as we talked in the previous section, right? So you have one authorization server which is allowing here the subdirectory validation. Okay, so here you can see you have the your OAuth callback endpoint is https your OAuth client.com/OAuth/OAuth provider callback, but what you are registering as at authorization server is https your OAuth client.com only, and you are having the design for the allowing of the subdirectory validation. That means if the request is coming from the client, the address what we see for the OAuth callback endpoint, it's going to allow because you have the subdirectory validation allowed. Okay, now you have an excerpt of the request originated by your OAuth client. While performing, the OAuth integration might look like this. So the URL will look like this only. Yeah, so like this http OAuth provider.com/authorize, then you have the query as a response type code and client ID, scope, state, redirect URI. So this is the kind of address URL I'm saying that the client will craft, and then it will just redirect you to the ping to the authorization server side. This particular OAuth provider adopts the allowing subdirectory validation strategy for redirect URI and therefore validates only the start of the URI and consider the request as a valid, as I told, right? Because you have the subdirectory validation allowed. If everything else is appended after the registered redirect URI, hence the registered redirect URI is perfectly valid under a functional point of view and things are good so far. Okay, let me go to the next, and these all sessions are put it in the that repository as I shown you in the previous section under the GitHub part, right? So you can just go and check this. PPT is also there. Sorry. The attacker also needs to be able to create a page on the target side underneath the registered redirect URI. For an example, you can see, so you have your OAuth client.com. So what attacker will do, it will just put like /user generated content /attacker page.html. It will attach that HTML page to the redirect URI address. Now you can see how the URL will look now. So you have the https OAuth provider.com/authorize, query parameter, response type code, client ID, scope, state, and then redirect URI will look like https your OAuth client.com/ user generated content slash attacker page.html. Now this is the address that attacker has crafted, right? And here the authorization server is going to allow. Why? Because you have the subdirectory validation, right? Now you see how the problem is going to come from this. So by using this, it will just make the victim click on it through any number of phishing techniques. So now attacker will try to hit this link by some way, right? Any phishing techniques you can say. So note that the crafted URI contains a redirect URI pointing to the attacker's page. Now the address is not the legitimate, it's the attacker page, right? Which is a subdirectory of the valid registered redirect URI of the client. The attacker was then able to change the flow as shown in the below diagram, you can see. So it seems that the request will go through resource owner browser to the authorization server, and the authorization server will issue a code to attacker here, not to the client, right? Because here it just by putting that address in the redirect URI, it's just going to get the authorization code to the attacker side, not to the client. Okay. So in this way, there is a chance of the stolen of the authorization code. Since you registered the your auth client.com as a redirect URI, and the OAuth provider adopts an allowing subdirectory validation strategy, so this address is a perfectly valid redirect URI for your client. That is true, because you have a dead design in at your authorization server, so it's going to allow and going to send the authorization code to this address. So let's have a look on the previous things we have learned. So often resource owner needs to authorize an OAuth client only once. This means that all the subsequent calls will skip the manual consent screen as long as the server believes the request is from the same client and for the same access right. That means what I'm trying to say here. So if you have already a session established, right, from the authorization server, so it will not going to check all the time. It will not look for the user consent, resource owner consent at every transaction because you have already a valid transaction, a valid session. So people tend to trust companies that have proven records on security. So there is a good chance that this does not switch the anti-phishing alarm on the user. That is true. That said, now that this is enough to convince the victim to click the crafted link and go through the authorization endpoint. The victim then will end up with something like your.auth.client.com slash user generated content slash attacker page.html with a query mark code is equal to whatever the code issued by the authorization server. Right, so this will look like once the code has been issued. Okay, so note the code request parameter ends up being attached in the URI of the malicious post. So you might be thinking that the attacker would need to have access to server-side processing in order to extract the code from the URI. Functionality generally not available to the user-generated content pages, or perhaps the attacker would require the ability to inject arbitrary JavaScript into the page, which is often filtered out from the user-generated content. However, let's have a closer look at the code of attacker page.html. So here the attacker attached that address, right? Attacker page.html. So you can see how it's going to fetch the code from this address, from this page. Okay. One second. So this simple page could look completely normal to a resource owner. In fact, since it doesn't even have any JavaScript or other functional code, it could even be embedded into another page. But in the background, the victim's browser will load the embedded img tag for a resource at the attacker server. In that call, the HTTP referrer header will leak the authorization code. So how you're saying how the authorization code is getting leaked? Through the HTTP referrer only. Because the victim's browser is loaded the embedded img tag, the image tag, right, for the resource at the attacker server. The extracting the authorization code from the referrer is simple for the attacker because it is delivered to him with the HTTP request for the embedded img tag in the attacker's page. So now it's easy for the attacker to get access to the authorization code from the referrer, right? So yeah, this is some diagram. It shows for the attacker, victim, vulnerable client, and authorization server. So by this, what is happening? Like, because user is just thinking that user is unable to identify. It's not an It's not any anti-phishing alarm or anything through which user can understand, because somehow user clicked that link, and that link basically went to the authorization server. Maybe might be you have already a session established, so it not ask for the user consent also. It generated the authorization code and just send that what we have seen in the previous, right, to that callback address what attacker has built. And now this attacker is just trying to get the code from the referrer, right, because the victim's browser here loaded the embedded img tag for the resource at the attacker server. So in that call, basically the HTTP header, referrer header will leak the authorization code. So the authorization code basically get hijacked here. Now you can say that, yeah, what attacker can do with the authorization code, because once you have the authorization code, you need to go for a token call. And for token call, you need, like, if I can say, for the auth code flow, we need a client secret, and the attacker does not have the client secret. So attacker will not able to do anything. That is true, but at least you have missed the authorization code. So maybe somehow if attacker can able to manage the secret, then yeah, the token is easily delivered to him, and then yeah, it can just access some resources and maybe just do anything, right? It can be a security breach, and it can be like the issue for your company's data and documents. So this is a way, like, by a small mistake or by a small by the simple strategy from the authorization server side, like allowing of the subdirectory validation, you went into this problem, right? So yeah, this is just like an example, like for the referrer policy from HTTP to HTTP, HTTPS to HTTPS, HTTP to HTTPS, but not from HTTPS to HTTP. Okay, so the URI in the attacker's post must be an HTTPS URI. Indeed, as per section 1513 encoding sensitive information URIs of HTTP RFCs 2616, client should not include a referrer header field in a non-secure HTTP request if the referring page was transferred with a secure protocol. That's the example it says, right? That's what it's mentioned. From HTTP to HTTP as a referrer is allowed. From HTTPS to HTTPS is also fine. From HTTP to HTTPS is also fine, but not from HTTPS to HTTP, as it mentioned here, right? It's not going to, like, client should not include a referrer header field in a non-secure HTTP request if the referring page was transferred with a secure protocol. That's example, yeah. So the basic understanding here is to we are not supposed to allow the subdirectory validation for the redirect URI from the authorization server side. When you're designing that, maybe right now if you can just go to any product where the paying Okta, these all have already the strategy to do the exact matching to avoid all this hijacking of the authorization code or other things what we see, right? Yes, this is the end of this session, and we need to talk one more session for this authorization code part. Registration of the redirect URI. So we covered this in this section for how the authorization code can be hijacked, and let's just talk to another one. And I'm just putting the description all on this PPT, because maybe if you just want to later also want to see the PPT, you can download from that GitHub repository and just watch. Maybe just read those if you want that. That's why this is little descriptive. Okay. If you have any question, please put in the comment section. We can discuss again. Thank you.